Hey everyone, Vidhu here. Welcome back to another video. Today we're going to be going over how I made my two previous videos in Manim. I'm going to be going over the coding, the thought process I was going through, and my setup. Let's get started. So first, Manim is a Python library used for math animation. Created by 3Blue1Brown. There are two editions, Manim GL and Manim Community Edition. I use Manim Community Edition, but I started off with Manim GL and then switched to Manim Community Edition in my second video. But let's open up a terminal and let's go into the file. So since it's using Python, you create a folder. In this case, I'm going to go into my second video about the dottie number. If you haven't seen it, go check it out. It's in the description below. Go into the dottie number, and I'm going to be using NeoVim to look at this. Pi. And now we're in this Python file where I've imported Manim. And while this might look complex, it's not that bad, honestly. These classes are basically just the different scenes that you have, and each of these equation where it has a text or a math text is just a function that's going to be displayed on the screen, where you just define what the function is and then you write it, and then you wait, and then you do something else with it. And these functions, where the for underscore and range function means I just don't have to use the I in case you were just doing for I in range. Makes it easier. And what this is doing is, in my video, you can see where I keep cosigning the answer to a function and recursively keep doing that. And the way I did that, instead of just hard coding it, I used a function, which in this case, I just set the result equal to the cosine of the result, which is why I imported math. Then I put that into a latex file, or a latex equation, where I just showed the cosine of the rounded result to 3 decimal places, and set that equal to the cosine of that. So you can just it just keeps going in as many times. I do that 3 separate times, just changing the speed. And then for the second scene, it's a little bit different. I use these math text ones in a V group, which is basically just an array with math text. And so as you can see, you can set each of these lines. So in this case, lines is our array. And so lines 1, 3 would be the second one, since it goes 0, 1. It would be the second one. Let's just go down there. Line second one, and the third part in that. So as you can see, there's a one part here, one part here, and one part here, and one part here. So this goes 0, 1, 2, 3. So this is our 3. And so it sets that equal to gold. And all of these comments, they're just me switching from ManimGL to ManimCE. You don't need to worry about those. Play underscore KW is a parameter where I set the runtime. So I can call this whenever I want, and it'll set the runtime equal to 2. I just write this first line, wait 5 seconds, and then this is an inbuilt function into Manim where I transform the first line into the second line. It maps maps parts of the function into another part. For example, if I go to this part, you have the question mark, and that is going to be mapped to this X. So it's going to try and transition that question mark into the X. And Then it just does that same thing over and over again with the play_kw as the argument, so it sets the runtime equal to 2. This just is another inbuilt function where it creates a rectangle, you animate the creation of it, then you fade it out. This is the interesting one, where it's class graph. This is using OpenGL, which is this moving camera scene. It starts off pretty simple. You just have an equation, a text equation. But this is how you draw a graph. So you set axes equal to the function axes with the x range and the y range. You set the length and the height. And this is just the configuration, like you can include the little tip at the end, you can exclude some numbers, and you can add the coordinate points. You center it, and you create labels, so like x and y at the end, you set the colors of them. And these are the graphs that you are willing to plot. So in this case, you just do axes.plot equals to the lambda function, which is just a one-liner function, where x is mapped to math.cosine x, which is just the function y equals cosine x. And from 0 to 4, and it's green. The second one is the same thing, except the function y equals x. Then it's going to write the equation at the top, so 10 lines up. But yeah, so it's going to write the equation. Then it's going to draw the border and the axes. Then it's going to draw this first graph, the cosine graph. Then it's going to draw the x graph. And then what this is doing is it's creating a dot. We haven't drawn the dot yet, but it is creating a dot at the point which I want to, if you can see in the video. And then it creates the colors, it creates labels, and then it'll create the dot. And this is where it gets interesting. So I wait 3 seconds, and then this is where the moving camera scene comes in. So if I go 23 up, you can see this is a moving camera scene. But this camera save state, what it does is it's a function for OpenGL where it, not Manim OpenGL, this is just an OpenGL part using a renderer, which I'll talk about later. This is still in Manim CE, where it saves the state of the camera. Imagine your video is a camera, and you want to zoom in. The point of this is to zoom in. In Manim, you zoom in by scaling. You scale the camera to a smaller number so it zooms in to a point. In this case, it would be to a dot here, which centers it at the dot. Now, if you wanted to zoom in, you could do this, but if you wanted to zoom back out, you would need to scale this. So you would need to do 1.2 times, 3 times, and you would need to mess with the math. Rather than doing that, since you can save the state of the camera, later down here, after you're done creating everything, you can restore the previous state of the camera, and it'll bring it back without changing any kind of scaling options. So in this case, within these lines, it'll save the state of the camera, zoom into a dot, and then restore the previous state of the camera. And other than that, this is just a bunch of latex, animating, fading away. But that was the main thing. And this creates that smooth zooming in animation and zooming back out animation that, in my opinion, looks pretty good. So let's actually see how we can use Manim to see this, how we test it. Now, the way you do this, it's different between Manim GL and Manim CE, but for Manim CE, you do manim-pq, which would be to set the quality. So in this case, I want high. You can set the renderer, which I like OpenGL, so renderer equals OpenGL. If you want the basic one, you can just delete this. And then if you want a full screen, you do -- full screen. You set the file, so dnum.py, which is what I coded in. And then you set the scene. So in this case, let's use the graph scene, since that's what we've been talking about the most. And then you click enter, and it'll open it up. It'll show your scene. As you can see, these scenes. I'm going to speed this up, since if you want to see it, it's in the description. Okay, so that was Manim, how I use Manim. If you want to know anything more about how I use Manim or just any other questions, put it in the comments below. And that was it. Goodbye.